Hello and welcome to Ubuntu AI podcast. I'm Andrea and together with Maciek, we will be your hosts. From fun experiments to enterprise projects, AI became the center of attention when it comes to innovation, digital transformation, and optimization.
Open source technologies democratized access to state-of-the-art machine learning tools and opened doors for everyone ready to embark on their AI journey. Ubuntu AI will be your guide in the industry where a community of like-minded people meet to make an impact.
Maciek, we are not alone today. We have a very special guest, and we will also have, I think, a very interesting and trendy topic, at least. Together with us, we have Gustavo Sanchez. I hope I pronounced your name correctly. Gustavo, would you like to introduce yourself before I dive into the topic?
Yeah, sure. I'm Gustavo, an AI solutions architect at Canonical. I work with Maciej, working with customers to do not just the solution, but implementing them from cloud infrastructure to not just AI, but also data platform solutions.
Welcome, Gustavo. I hope you'll have fun today. And my very first question is fairly broad, but I know lately you spent some time on smart cities and how artificial intelligence can help them. Can the cities become really smart by leveraging AI technologies?
Yeah, definitely. I mean, you can find it pretty much everywhere. And when we talk about smart cities, that's a way of, centralizing all these different use cases of using AI into a single one. Because you can see from retail, on camera detection, taking a look and seeing if someone is stealing items from your store. You can also use it in industry, like taking a look with cameras to do quality assurance. You can also use it on the machines themselves. You have some sort of automated robots with hands that move things around. And, all this sort of fun stuff you can see pretty much everywhere, from retail, agriculture, to also healthcare and many other use cases.
I'm going to give away some secret. I know this is your topic for Nvidia's GTC conference that takes place at the end of March. And you already mentioned Edge AI. I would be curious, and Maciek, feel free to also dive in, because I know you've been working on some projects as well. Is Edge AI the answer that edge devices or that the devices have been waiting for in order to leverage and AI solutions and actually get return on investment?
So maybe before we jump into that, Gustavo, can you tell everyone what edge is from our point of view? Because different people consider it different things. So for some people, edge ends next to the camera and the processing there. For telco people, edge might be like 6-rack data center on top of the building. So what kind of edge are we talking about here?
Right. So edge, we're talking here really close to the end user. Stuff like smart cameras, drones, tools, smart tools that you can use in health. So really, really close to the end user. Almost you can say edge / IoT.
Okay. And what are the main difficulties then? Because, the edge IoT problem by itself is sort of solved. There are a lot of devices, a lot of people manufacture them. And this seems clear on how to put software on a small machine somewhere out there. What is then complicated about introducing AI into the picture?
So couple stuff. One, you can talk about efficiency. Again, you always care about efficiency on small devices because you don't have tons of resources on them. So the same goes for the GPUs. And especially you want to find a way to distribute the usage of your GPU across all your different processes. Because it might not be that you have only one application running, you might have multiple of them, and they might be fighting for that GPU resources over there. And when you are using edge devices, IoT use cases, the most important factor is real-time insights. So you want to have low latency on the responses, on the inference you're doing. So that's one of the factors to really take into account. How can you do GPU management on that small device to actually use it efficiently and also don't have late responses when you're trying to get, real-time insights from them? That's one of them. So I can keep going or we can deep dive into that one. What you like to talk about.
I have a question, which is maybe a bit of a newbie question, but is it really secure to have AI on the edge devices or on the on such a small device, even to have models there?
So that's another challenge to solve, actually. I mean, security, you touch on another important one, which is that because it's not just about having the data, because you're going to have probably localized data that's very sensitive. You might also have tons of data stored. I mean, talking about a challenge that goes from the data center up to the edge, which is security, you have a responsibility with that data. And then obviously, the closer you are to the end user, the more, let's say, vulnerable you are to vector attacks, because there might be a hacker around, someone who can play with it and try to notch in your device. So it's very important to take that into account in different ways. And we have been working through security on small devices for a long time with what we call Ubuntu Core and Snaps, which it's a way to securely have your software one in a read-only manner, but also kind of isolated one application to the other. The same way you can have containers, you can also have snaps, which containerize an application, and you have another layer of isolation and communication between them. And it's also important to take into account auditing and taking a look into the packages you use from the hardware, like drivers, GPU, making sure everything is secure, to the OS, up to your application layer stack. Like, hey, are you patching your Python packages? Are they secure? Do you have any sort of leakage and CV critical vulnerability out there that you need to be aware of? So it's about monitoring and auditing all your devices.
It's very interesting, Gustavo. So if I get it correctly for now, in terms of like why doing AI at the edge, we have efficiency on one hand, we have security on the other hand. What about maintenance? Because if there's something that we clearly know is that if you deploy one model to an edge device and you just let it stay there, it's going to be outdated very soon.
Yeah, that's a big point. We can call that operations or day two operations. And that goes from scalability to how can you manage not just one device? Because you might say, okay, I might just go to the site and update the software directly, physically, but you need to have a way to manage all this distributed system where you have, devices all around the city or maybe across the world in really remote places. So it's about scalability. How can you manage all those devices from a centralized place? And how can you do updates, upgrades, backups, and restores out of them? And it's operations, and the operation is also about reliability. So how can you actually do an update, but minimize your downtime on that device? Because it's not just providing the update and, turning off the machine, restarting it, and then having the new software, because there might be someone on the other end, depending on an insight coming out of that device. I'll put a simple example. Maybe you have your vacuum cleaner cleaning your room, and then you just stop it, and people are like, what just happened? I mean, I just want to get the new software at some point. And the same goes for some more critical use cases like in healthcare. So that's another important constraint. And a couple way to manage that is being able to have a way to provide that software, not so much on a going inside the software and pulling, but it's more of a subscription model where everything is automated. And you just say, okay, here's the new software, and everything just gets triggered to get the new update without having downtime on them.
I like you actually captured another benefit, and then you also captured maybe some interesting use cases that I think are really important because depending on the industry, there are different needs and different challenges. Maciek also pointed out the telco ones. What's the role that open source plays in it? Because I'm not an expert on the edge side or on the IoT side, but I do have a feeling that often things are closed source on that side of the spectrum. Maybe I'm wrong, maybe I'm not, but does open source play a role, and how do we approach this?
Yeah, definitely. And obviously, we're open source people to the core. And what we see in the current solutions is a couple limitations. One is definitely vendor lock-in, because there are some public cloud solutions. I put a couple names like AWS Greengrass, Azure IoT, which is okay if you're just using a single cloud provider, but it can become a little risky if you're already having like a multi-cloud, cloud agnostic strategy, or if you're trying to really scale out, that can become really costly because you're renting usage rather than owning your stuff. Similar to when you rent a house or when you buy it. So the same goes there. You need some way of having like an on-premise, which means like having on your private data center your own solution. And that's where we come in. Like when it's not just about the cost, it can also be about data privacy and compliance. For example, governments, they might have some constraints about using some public clouds, storing data over there, like governments, banks, healthcare. And also, it can be not just about privacy, not just about cost, but it can even also be about performance. Because maybe the resources you have available in public cloud, they get to a certain limit. And you want to really optimize, not just having like a big machine, but having an optimized way with multiple big machines and how they can communicate with themselves. Like, and then you can start considering technologies like Volcano and this sort of cross machine scheduling with GPU, like really low level optimization, because you might be training like a really big model. So that's when, having an on-premise solution can become really important. And also considering having like a cloud agnostic, because you can still use open source on top of public clouds. And that's fine. Those are a couple of the limitations we see. And the last, and I think is the most important one, is that we see some of these are complex to operate. And in general, what we do at Canonical and we try to do with these open source technologies is to simplify complexity for you. So we try to take something that's really complex to operate, like how do we manage all this? And rather than you having your own custom pipelines on how to do this stuff, we can provide guidelines in really standardized way on how to do them. So it becomes really easy for you to drive the car rather than letting someone else drive for you.
So I have one more question coming back to this because you mentioned about like utilizing resources efficiently and you talked a lot about GPUs. Is it something that's fully required or can we do inference on CPU on edge devices? Like how the landscape of what we can actually use looks like?
So you will definitely want to use at least a really small and not that powerful GPU over using just a CPU, because CPU is meant to do things sequentially rather than in parallel. And when it comes to AI, everything works like in parallel, like in a matrix, like in a multi-dimensional stuff, many things happening at the same time. And that's when you want to use GPUs because they're more parallel processing oriented than a CPU. So you'll definitely benefit from using really old and small GPU over a really good CPU.
Okay, so you've talked a lot about the devices themselves and the models running there, but where do these models come from actually? So, okay, I have a fleet of devices. I'm a company that creates security cameras. I want to put some facial recognition or whatever there. But how these models land there? Where are they coming from? How this part works?
Okay, sure. So there is this whole idea, you probably may have discussed it over the podcast in previous episodes on what we call MLOps or machine learning operation. And you can see this in a way to simplify this concept is just seeing it as a CI/CD pipeline, but for AI models. So it's about having this, what we call a training environment where you actually create your model, which is typically a bigger place. I say bigger in terms of resources, more beefy with GPU, RAM, CPU, whatnot, where you train your model, which again can be a public cloud or a data center you might have. You create this model and this whole pipeline goes from, and I'm going to really simplify it from just experimenting with an IDE like Jupyter Notebook, creating some Python code. And out of this, the output is a binary and that's what we call the AI model, the binary that comes out of it. And you can see it as equivalent of an executable file from the software point of view. And then we have these pipelines in these MLOps world where you can trigger auto deployments of these to put them inside your devices machine or package it, because you can package this software different ways. You can package it to be run on Kubernetes. You can package it to run on with like embedded within your mobile application, or throw it into your edge IoT devices. And that's kind of how it works. So you start from one place where you train stuff, and then you put it out there in the world. And I'm trying to create, like, I'm just trying to think of an equivalent way to say this, to simplify it. And you can see, like, going to the university, you might spend some time there in that place, and then you go out to the work and you actually do the work. So that's kind of an analogy to it.
I have a question now. Do we have any restrictions in terms of devices? I know that during your GTC talk, you're talking about Nvidia's Jetson modules. Are those the only types of devices that we can leverage or deploy models to?
So, I mean, and it becomes a similar discussion to, are there more GPU brands out there than Nvidia? And there are. It's just that this is the most known and easier to operate. And a second point to it is that Canonical and Nvidia has worked together in a partnership for quite some time. Many things that work there, like on Nvidia, if you're familiar with something called a DPU, which is a data processing unit, that's based on Ubuntu. And the same goes for drivers. We try to really optimize for integration with NVIDIA open source part. And that's not just with that, but also, hardware certification for really big machines like TTX 8100 to small devices like Nvidia Jetson devices. So yes, there might be another options out there, but you want to go with something that works out of the box, that is really efficient, that is really powerful, that is known, and that is certified, and that is secure. So that's why, at least on or experimenting, we're using NVIDIA Jetson devices, which are these really small set of Raspberry Pi like, but with a GPU attached to it that can do all this inference on the edge.
So I think we talked a lot about your talk, but it's like GTC is a big event and there are tons of exciting things. So what you are looking for? What kind of topics you want to dive into and see on this year's GTC? What excites you the most of like recent AI developments?
Yeah, definitely. So I'm really excited on the big machines and seeing how we're optimizing, like, I'm going to say high bandwidth sort of solutions. Like, how are we actually training big stuff like ChatGPT sort of solutions? How are we optimizing all that? How are we doing cross cluster training? How are we optimizing all that? And the same for big bandwidth again, and in this case, more towards networking. How are we using the DPUs? Because I'm really curious to see what are other use cases to use a DPU, not just passing data around and moving it from one place to another. It's a powerful smartly. But I'll be also curious to see, are we processing that data on real time in different use cases? That's something that's really, like, drives questions to my head. And I'd like to hear also from you, Match, if you have any insight or what you like to see on this new session of the NVIDIA GTC.
I mean, currently I'm looking mostly into new types of hardware being utilized in context of an edge, like new architectures like RISC-V and dedicated hardware to do ML inference. That might be super exciting. The other part that I'm looking at is migrating legacy HPC stuff, Slurm-based workloads into Kubernetes-based MLOps. So these are the two things that will be talked about a lot. And last but not least, I'm also excited about the internal networking of GPU clusters. So the introduction of Spectrum X and everything that will be announced there, and also how to migrate existing InfiniBand-based data centers into Spectrum X. These are the three key topics that I'm looking for.
I also think that it will be interesting to see how the latest and greatest, if we think of Gen AI and all these kind of applications that made the tour of the world, I would say last year, the year before, I'm quite curious to see how they get integrated for edge devices and how the challenges when it comes to, for example, size, Gustavo, as you mentioned, are going to be addressed. I think that will be interesting. And I would also expect some very interesting demos and use cases for customers. Similar to our smart city use case that we discussed about, I would expect some others as well. We don't have a lot of time left, but before we get into that, and it's a question for both of you, Maciek and Gustavo, I would be curious, how do you see the market evolving? I think at the moment, Edge AI is a big topic. It's a hot topic as well. Open source obviously helps it out. Security, efficiency are some of the main benefits. There are also clear challenges. There's also an architecture challenge, I would assume. How do you think it will evolve in the long run? Maciek will say now that, I don't know, this landscape moves too quickly, but let's see.
Well, I let Gustavo start then, as you know my answer already.
Yeah, I guess, I have a similar opinion, but let's see. So the good thing, and that's the importance of having these sort of sessions and discussions with people doing different stuff, is, really opening your mind to different architectures that are out there. Is your architecture or what you're trying to do really the way to do it? Because it's not so much on, the end result as how are you trying to solve it? Is that the proper way? So should I think out of the box and see how you are actually trying to achieve things? And I think more and more we're seeing this isolation of stuff because of multiple reasons. Like when I was talking about isolation, so application, this means security, but this also can mean stability because, like Matthew just said, we have all these different versions coming at like one version changing every day for all the hardware. You have this complex ecosystem trying to work together and put all those pieces to actually function. And that's when having isolation comes important because you have all these, Dockerized sort of solutions or you containerize, you can call them different ways where all the versions are, matching and how they should work properly. And then when it comes to testing multi-ecosystem, that's also like another big challenge that I think people should start tackling more and more, not just, hey, my database works here, my AI model works here, but can they work together? Can you make that whole ecosystem that is very extend into the things we can do? Because it can come from video storing, SQL, NoSQL, and those sort of stuff, making it all work together. That would be awesome to see out there.
I have a follow-up question, Maciek. I know you owe me an answer, but do you think AI at the edge will become a commodity? Is it going to be so natively embedded in the edge devices that we will not even realize it's out there? Gustavo saying yes without saying yes, I feel like. Maciek, what are your thoughts since you owe me an answer as well?
So I think that it will get embedded more and more, but we will rather see ready-made solutions like black box ready-made models to analyze videos instead of everyone trying to build their own, because most of the small edge use cases are fairly repeatable and it doesn't make sense to. It's like with large language models, like everyone is talking about using them in a project, but only like 5 or 10 companies actually train those models. The rest is just using an open source model that someone else trained. And coming back to your question, actually, there is a couple of things that we start seeing by doing more and more projects in terms of like what the future holds. And I think that the two interesting aspects is that most of the AI projects are currently not focusing on ML or MLOps, but rather on the data preparation stage. There is a lot of work being done about providing clean and reliable data pipelines to feed the models. That's one very important area. And the other is focused around observability of the entire infrastructure of inference and hosting the models, because people started building first POCs, they move them into production, and now there is this kind of tricky moment where, okay, something doesn't work, but I really don't know why. And answering those questions and being able to reliably do distributed tracing from a model endpoint to what kind of data set was used to train it, what feature set in the feature store was actually utilized, and so on, and being able to even not find out the reason, but at least get all the data points that we need to look at on one view. That's a problem that we will have to solve this year.
It looks like you'll have some fun ahead of you, both of you. Since we're getting close to an end, I have my usual question. Do you have a thought for the AI of tomorrow? And since this season, I took the promise to also have my answers. When it comes to edge AI, I think that the AI of tomorrow includes AI at the edge by default. It will be embedded in our lives so we don't feel it, but then it will also make our lives better from feeling more secure because I know ambulances are prompted right away when an accident happens, to having better experiences because, I don't know, a robot can guide you through the store to buy your stuff. I think it's really all for the best of people. However, there is going to be way more data captured, and then the need for improved security systems at the edge is going to be crucial. Gustavo, would you like to go next with your thought?
Yeah, my thought goes through just, I think open source is going to start being everywhere, not just on the infrastructure layer and, the tooling we use to build these models like PyTorch and TensorFlow, but even go to the model themselves, because we're going to start building these community share models that someone can train and then share with the rest and fine tune. And I think that's going to start, going broader than just LLM, but also to edge AI use case and many more, just trying to start creating open source models.
Maciek, what about you?
Well, since this is a special episode, I have a thought for all advanced senior practitioners with a lot of years of experience in ML, MLOps, and data processing. Find someone who you can teach and train. Look for someone who is smart, knowledge, and success hungry. Like I have Gustavo here from my team, and I feel really proud about him speaking on GTC and getting up to speed with a lot of things. And as you can see after this episode, I almost didn't have to speak anything on the podcast, and still we have an episode. So it also saves you a lot of time.
Well, that's very sweet, Maciek. And it's something important to talk about. How do we upskill and how do we talk and how do we learn about machine learning? It's a wide topic. It's being approached often, but then how do we learn about it is important. Maybe we have a podcast about it with some of the folks that we know upskilled quickly. But I think for now, this is it. Thank you for your time. This was Ubuntu AI, but your AI journey stops here for now. We'll meet again in 2 weeks with a new episode. In the meantime, follow more articles from us on Medium. See you soon.
Bye.